Hey guys, it's Chris at Highline Guitars. You're watching another one of my YouTube guitar building videos. If you're new to the channel, welcome. I hope that by the end of this video, I'll have earned your subscription. And of course, to everyone who's watching, if you enjoy this video or get something out of it, I would really appreciate it if you would click that thumbs up button down below. It doesn't cost you anything. YouTube isn't going to spam your inbox with email, and you're certainly not going to download any malware. Okay, so what I would like to talk about today is part 5 of the electric violin guitar project. And yes, we're finally ready to start cutting out some parts. And that's what I'm going to be doing today. I'm going to start by cutting out the fingerboard. Now, I have to keep telling myself, fingerboard. Call it a fingerboard. It's not a fretboard. Guitars have fretboards, violins have fingerboards. If it's got fret wire on it, it's a fretboard. If it doesn't have fret wire on it, it's a fingerboard. So I keep trying to tell myself that. So if I slip up, I apologize in advance. Don't feel the need to correct me in the comments section. Okay, so the reason why I'm making the fingerboard today is because, well, it's really tradition. When I first started building guitars years ago using my bandsaw, my drill press, and my planer, and all my chisels and spoke shaves and stuff like that, I would always start by making the fretboard first. Then I would make the neck, and then finally I would make the body. The reason I followed that order is because I would use the fretboard to lay out the shape of the neck. Then I would use the neck to lay out the shape of the neck pocket in the body. So that order made sense, and it always worked. Well, with CNC technology, I don't have to do that anymore. I can make the body first and the fretboard next, and whatever. It doesn't matter because everything is so precisely machined. However, I still like to follow that tradition. I like to make, in this case, the fingerboard first, and then I'll make the neck. And what that allows me to do is to bring the two together, glue them up, clamp them down, and then set them aside to dry. And while that's happening, I can make the body. As a result, if I really was motivated, I could make the entire instrument in one day. I know that that's probably not important for a lot of you watching because you're not in any rush to make the instruments that you're going to make. And I would totally agree with you. I like to take my time as well. In fact, I'll probably make just the fingerboard today, and then maybe tomorrow I'll make the neck, and then the day after that I'll make the body. But if I really wanted to, I could do it all in one day. And it's useful to know that because I know there are a lot of you out there who are going to try to make a business making instruments. And oftentimes when it becomes a business, volume becomes an issue. So you want to be able to make the instruments quickly so that you can move them out the door and start on the next project. In this case, though, I don't have to rush it, but that is the order that I will follow. Fingerboard first, neck next, and then the body. So I'm going to bring you in and show you how I'm going to get all this ready. Okay, so what I'm going to show you, I've talked about before in the past, but it always bears repeating, and I know that for many of you this will be new information. But the way that I will position the blank on my CNC's wasteboard is I have lines that are engraved in the surface of the wasteboard. And I have one line that is at the very center of the x-axis, and it runs parallel to the y-axis, and it runs right down the center of the board. Now, since this machine has a working space of 48 inches in width and 48 inches in length, obviously this line is right at 24 inches from this side and this side of the y-axis. So it runs the whole length of it. Then I have another line that runs right along the center of the y-axis, but it's parallel to the x-axis. So I have basically what forms a big cross here. And these lines were cut using a 32nd of an inch diameter 2-flute spiral upcut bit with my CNC machine. I just milled those lines. I have another line that is parallel to the x-axis, and it's actually 18 inches from the front edge of the working space. And the reason I have that is so that I don't have to lean so far in with some of the parts that I use. I can just position them here. But having these lines creates a center point which is precisely located from the machine's home position in the corner. So what I'll do is I'll home the machine, and that moves the entire spindle all the way to the lower left corner of the CNC machine, where limit switches are tripped and it stops the movement of the machine. And at that point, the controller knows that is the home position. From there, I can jog the spindle 24 inches over to this line, and then I can jog it back 24 inches to this line. That places the center of the spindle right over the very center of where those two lines intersect. So now I know exactly where the spindle is located on the wasteboard. From there, I can move it to wherever I intend to have the home position for the blank that I'm going to cut. And in most cases, I put the home position right over the lower left corner. So if I have this the blank positioned right here, I know that from this point forward to here is half the length of the blank, and then from here over to here is half the width. So by positioning it, by jogging the spindle to that position, I will place the spindle in the start of the workpiece home position. Now, if you're wondering, how do I position the blank precisely on the wasteboard relative to these lines that are engraved, I have a center line that is marked across the length or along the length of the blank, and then one that runs across the width. And then I've extended those lines down the sides, and I will use those lines to mark or to line up the blank relative to the lines that are engraved in the wasteboard. And in this case, I'm going to use this center line, but then I'm going to use this line that's at 18 inches, so it's closer to me and I don't have to lean further over when I go to clamp it. Now, I have a piece of tape here, and the edge of it is a continuation of the center of the line that's engraved. And the reason for that is because there is a hole drilled in the wasteboard that mounts the wasteboard to the frame. So as luck would have it, my blank the center ends up right over that hole. So I use that piece of tape to kind of help get it lined up. But then what I'll do is I'm going to make sure that the lines on the sides are lining up precisely with those engraved lines. And it takes a little bit of fiddling around, but once I get it, I can then start the process of clamping down the piece. Now, this method works really well. This positioning method works really well for getting the blank positioned so that the carving operation will cut the piece out of the blank exactly where I want it to be cut out. But it also serves a purpose in that if I'm doing two-sided carving, which is what I'm going to be doing with this fingerboard, I'll cut one side, then I'm going to have to flip it over to cut the other side. And again, I'll use these lines to precisely locate and position the blank so that when I cut the other side, it's going to line up with what was carved on this side. Hopefully that makes sense. It's pretty simple, but I use clamps like you see me using here to hold the workpiece into position. And every time I do this, I get comments from viewers who want to know why I'm not using a pin alignment system, or why I'm not screwing the blank down to the wasteboard, or why I don't use a vacuum system. And when I hear that, I think the people who are commenting probably don't have a lot of experience at this, because folks who do have experience will understand why I don't do that. Clamps are the most universal way of holding the piece to the workbench. It works in almost every situation. With screws, you got to make sure that the blank is big enough to accommodate the screws. With a vacuum system, you have to make sure that your surface is absolutely flat and that the surface that you're clamping down doesn't have any sort of texture or grain or pores or anything like that, because you can lose clamping pressure. And the reason I don't use a pin alignment system is because, think about it. With a pin alignment system, you have to drill holes in the blank to hold the pins. So how do you do that accurately? You have to precisely position the location of those holes in order to match up the holes that are in the wasteboard that will accept the pins. So it sort of becomes a what comes first, the chicken or the egg. So this method of marking out the center line and positioning it with the lines engraved on the wasteboard is super easy, super fast, and always repeatable. Okay, so I've got the blank clamped down to the wasteboard, and I've got the center point of the blank right over where these two reference lines that are engraved on the wasteboard intersect. So what I need to do now is I need to home the machine. Then I'm going to need to jog it to place the spindle right over the center of the blank. From there, I can then probe the bit to determine the z-axis height. Then I will reposition by jogging the spindle to this lower left corner. The spindle has now been homed to what we call the machine home position, which is this lower left corner. This is now a known position. The very center of this spindle is positioned precisely to what the controller knows to be home. From there, I can move it anywhere precisely, numerically, and the machine's going to know where it is. But before I do that, what I need to do is install the bit that I'm going to be using for this first cutting operation. And for this first operation, what I'm going to be doing is I'm going to be carving a scallop shape into the bottom of the fingerboard. If you look at a lot of violin fingerboards carefully, you'll notice where the fingerboard extends out over the body, there is a scalloped shape there. And I'm going to be adding that to this fingerboard. I don't have to, but I like the way it looks. And I think will reduce a little bit of weight because I'm removing some material. And let's face it, violin fingerboards are fairly thick. So wherever I can remove material to save weight, I'm going to do that. So to do that, I'm using a 1/4 inch diameter 2-flute spiral upcut ball end mill. And I'm just going to install that into the collet of my spindle, and I'll tighten that down. And then once I have this installed, I can then jog the spindle over to the known position for the workpiece, which is going to be right over the very center of that blank. All right, so now the spindle is positioned right over the very center of the blank. And in truth, the blank should be referred to as the workpiece. You have the machine home position, and then we're going to have workpiece home position. Two are very different, but the machine home position will help to determine the exact position of the workpiece home position. So I have it centered right over the middle of the blank. What I have to do now is I have to position the spindle in the XYZ workpiece home position. And to do that, I'm going to start by probing the bit. And what that means is I'm using this device. It's a probe. And what this does is there's a current that once the bit touches this piece of brass, it's going to close the circuit and then stop the spindle from moving. That puts the very tip of the bit at a position above the workpiece that is equal to the thickness of this block. And because the controller is programmed to know how thick that block is, it will know exactly how high or how much space there is between the top of the workpiece and the very tip of the bit. That puts it in the Z home position. So I'm going to probe it right now. Part of the process of probing is to tell the software that these pieces are connected. So by touching the bottom of the bit, I will establish contact, and that's going to send a signal which instructs the software that contact has been made. Once that's done, I can then start probing. Now you'll see, or you'll notice that the spindle jumped up after the contact was made. That amount is predetermined. So now the controller knows that this bit is a very specific height above the surface. So that's how you get to the Z-axis home position. And once that's done, I can put all that probe away, and I can then jog the spindle forward to this edge and then forward to the lower left corner. Now, since this blank is 12 inches long and 3 inches wide, that means from here I have to jog back 6 inches and then 1.5 inches. And that's going to place the very center of the tip of this bit right over the very corner of the workpiece. So now the very tip of this bit is in the XYZ home position, and I am now ready to start carving the operations on this side of the blank. The scallop on the bottom of the fingerboard is now carved and it's finished. So what I have to do is loosen the clamps and then flip the blank over and reposition it so that I can carve the other side, which is going to be the radius. Obviously, before I can do that, I need to get the spindle out of the way. So I'm going to use a process called parking. And what that does is it will move the spindle 3 inches back from the far edge. So if the blank or the workpiece is 12 inches in length, add to that the 3 inches, it'll be 15 inches back from this point. That's beneficial to know so that I can quickly and easily reposition the spindle by simply moving it 15 inches forward, and it's going to be back in that exact same spot. So let me get that out of the way and flip that blank. The radius carve is finished, and it took about 13 minutes to do the carving, and that included the hogging out the wood with the rough cut, and then the finishing pass, which smooths the surface. Then the bit returned to the corner. And what I need to do now is swap out the 1/4 inch ball nose bit that I was using, and I'm going to replace that with an 1/8 inch diameter 2-flute spiral upcut end mill. And that's what I'm going to use to cut out the perimeter shape of the fingerboard. I don't want to use the ball end mill because it's not going to give the right kind of shape. So I think it's better to use a flat end mill. And it doesn't need to be 1/4 inch in diameter. It only needs to be an 1/8 inch in diameter so that it's not going to be removing as much wood. The more wood you remove, the less stability the part will have inside of the blank once the bit has cut all the way through. But then what I'm going to have to do is reprobe this bit so that the machine knows where the tip of the bit is in relation to the surface. But instead of moving back to the center, all I did was from the corner is I moved it a 1/2 inch over to the right and then a 1/2 inch back. And that's where I'm going to probe from. And once I have the Z-axis height set, I can then just jog it back a 1/2 inch toward me and then a 1/2 inch over to the left, and that's going to put it right in the XYZ home position. All right, so the fingerboard is now complete. The carving operations are done. There were 3 of them in total, and the total time it took to cut out this fingerboard or to fabricate it with the CNC machine was about 30 minutes. And that's being generous. It actually probably took a little bit less than that, but you do have to factor in the time it takes to probe the bit and do all that. But now I have the finished fingerboard. And if you look closely, you'll notice that there are tabs which hold the fingerboard into the blank. You have to do that because once this bit cuts all the way through the material, if there aren't tabs that are holding the part into the workpiece, it's going to cause the part to go flying around your machine. It can get damaged, and it can even become a dangerous missile. So we include those little tabs. And what I'll do now is I'll just take a small hacksaw or a hacksaw blade, and I'll cut those tabs, thereby liberating the fingerboard from the blank. Perfect. All right, guys, well, there you have it. A perfect fingerboard in less than 30 minutes. It's got this nice little scallop on the bottom, and the radius is nice and smooth. In fact, if you look at it up close, I don't know if you can see that, there are some very subtle tool marks, and I should be able to eliminate those with a quick pass of some 220 grit sandpaper, and then I'll probably work my way up through 320, 400, 600, 800, 1000, 1200, and then I'll polish it with my buffer. Get a nice, super smooth finish on this. But before that happens, I'm going to, in the next episode, which will be part 6, we're going to carve the neck. And that's going to be really interesting because, as you've seen in previous episodes, that neck is pretty interesting looking. And I will begin the process of cutting that out of a block of maple. So I hope you'll be around to watch part 6. It should be a lot of fun. So as always, if you enjoyed the video, give it a thumbs up. If you're new to the channel, welcome. If you would like to help support the channel financially and get something in return, like a nice t-shirt or some cool guitar plans or plans for making tools that we use to make guitars, be sure to either visit eguitarplans.com, there's a link in the description below, or you can visit my Highline Guitars merch store, which is displayed below the description for this video. At any rate, any support you can provide would be greatly appreciated, and I hope you'll be back for episode 6. So in the meantime, take care, stay safe.